Thanks, Foka. I hope you said nice things. So I'm going to start and pick on GitHub, tell you a few stories. This is a post by Tom Preston Warner about a year ago, 2012, in March. The title is Public Key Security Vulnerabilities and Mitigation. And what happened here was GitHub discovered that they had an issue where if somebody realized it, they could actually attach whatever SSH key they wanted to any user or repository in GitHub. And that meant that basically anybody's code could be cloned by anybody else. So it was a big problem. They went through the process of having millions of people audit millions of SSH keys in order to fix it. A few months later, this hit the LinkedIn blog, an update on LinkedIn member passwords compromised. So the issue here was that LinkedIn had somebody break in and steal a bunch of password hashes out of their database. They had to go through the painful process of notifying users that their passwords would have to be reset. And the bigger issue here is that those passwords might be valid for all sorts of other systems, right? I would bet that a ton of LinkedIn users also use their same passwords for their Gmail. So this is a big issue that they had to deal with, not fun for anybody involved. And most recently, RubyGems.org in January of this year was down for about a day because a vulnerability was discovered where a specially crafted gem could be uploaded and cause RubyGems.org to eval arbitrary code on the server. The risk here was that somebody would attach an attack payload to some gem which had already been published, and then people would start downloading it and run on servers all over the world. So they went through the process of verifying the checksums of hundreds of thousands of gems before they re-enabled push functionality and people were able to deploy their apps again. So today, we're going to talk about Rails application security in practice. You can't ever be sure that this sort of thing is not going to happen to you. But what I want to do is have everybody walk out of this room with a better understanding of the things that you need to worry about, the attacks that people are going to be trying to use against your application, and what you can do to defend yourself so that you don't get hit with something that you should have been able to catch beforehand. So to do that, we're going to start by looking at 10 different attacks that you have to be aware of if you're running a Rails application in production. We're going to look at a tool to help you secure your application, and we're going to do it all really fast, so pay attention. So the first attack I want to cover is session hijacking. This is like a really old thing, right? But how does it work? You've got a victim, and you've got a target server, and there's a session which tells the target server who the victim is. It tells them what permission they have on the site. Right? So that could be represented as a session ID, or it might be a encrypted session that just has a user ID in it and doesn't really matter. The point is anybody who has that can act as that user. So a session hijacking attack is when an attacker somehow observes the session information and then is able to start making requests to the victim server as if they were that user. And this has all sorts of problems. So remember a couple years ago, a tool called Firesheep came out. And Firesheep is a Firefox plugin that really highlighted just how easy it is to hijack sessions on a number of popular websites. And this was a big moment for session hijacking as an attack because everyone started to wake up and say, wait a minute, it's not good enough to just encrypt my login form. Maybe I need to be encrypting all of the page views on my site. So the risks of a session hijacking attack are pretty straightforward. You steal the user's session, you take action as that user. You can do things like change their password, potentially change their email address, and any action they have on the site. You won't have the user's password specifically, but if you're on E-Trade, you can make trades as that user. So what do you do about this if you're a Rails application and you want to prevent against session hijacking? So raise your hand if your app has sessions, if people can log into it. Raise your hands. OK. Keep them up. Keep them up. Your app has sessions people can log in. Now put your hands down if you require SSL on every page. OK, so the people whose hands, everybody put their hand down? No, there's a few hands up. The people who have their hands up have applications which don't have SSL required on every page, but they do have authentication. You need to fix that. So the first thing you're going to want to do to worry about session hijacking is to force SSL everywhere, and we'll look at how to do that. You're also going to want to make sure you set the secure and HTTP-only flags on your cookies, and we'll talk about how to do that. You'll want to use the strict transport security header. And finally, this is, varies depending on your application, but for any actions that are particularly sensitive, like changing your password, changing your email address, potentially making a purchase, you might want to cause someone to have to enter their password in order to complete that. Because remember, in a session hijacking attack, the attacker doesn't have the victim's password. Rails makes it really easy to force SSL across the board. Config.force_SSL equals true is how you'll do it on the latest Rails 3. I highly recommend you use that setting. As far as the cookies that we talked about earlier, make a request to your application over a secure protocol. And what you should see is at the very end of the cookie, it's going to say secure and HTTP only. Secure tells the browser never send that cookie over an unencrypted channel, and HTTP only tells the browser never let JavaScript access that cookie, which comes into play when you start talking about cross-site scripting attacks, which we're going to get to in a second. In your response, you should be sending back a strict transport security header. And what that means is you're telling the browser that this website requires SSL everywhere, and connection should only be made to this website over SSL. So the reason this is important is when some user goes to your website, they don't open up their browser and type in https://example.com. They just type in example.com. And the browser behavior by default is to go to the non-HTTPS version, right? So this tells the browser, when someone types in example.com, it doesn't matter that they didn't put HTTPS. Take them to an HTTPS version of the page by default and keep them there. And if the site comes back and isn't using SSL, just don't let them access it, because that's not how they're supposed to use that site. And the browser will remember that for a certain amount of time. The second type of attack I want to talk about is brute force attacks, which really comes down to hash functions. So when I say brute force attacks, I mean what happens if you're LinkedIn and somebody gets a hold of all of your passwords, right? Ideally, at a bare minimum, you're salting your passwords, you're running them through like a SHA function, you're not storing raw passwords, right? Like we've all moved past that. Nobody has this a password column with a bunch of passwords in it anymore, right? Okay. But it matters how you store them still. So when you're talking about brute forcing, it comes down to guesses per second. EngineYard did a programming challenge a while back, and part of it was about computing SHA-1 hashes as quickly as possible. So these were teams of amateurs who were basically trying to put together some computing power and compute SHA-1s as quickly as possible. Now, does anyone want to make a guess as to how many SHA-1s per second the winning team was able to compute per second? Anyone, start a guess. 4 million. Anyone got something else? There's a Code Climate t-shirt involved. There's only one guess. Okay, 3 billion per second. So when you do it, that's just a team of amateurs, right, for an EngineYard programming contest. This wasn't the NSA. So when you can run 3 billion SHA-1s per second, this is how long it takes to crack every variation of a password depending on length. This includes upper and lowercase letters, numbers, and common symbols. This isn't a restricted set of characters. You can see by that you have to get all the way up to like the 8 and 9 character ranges to even have something that's going to make it through the day. This doesn't matter if you're salting. Brute force is still going to get you. So what you need to do is use a better algorithm. You need to use BCrypt. And the big difference between BCrypt and SHA-1 and MD5 is SHA-1 and MD5 are designed to be really, really fast, and BCrypt is designed to be really, really slow. So it's like the best type of programming, right? So when you're validating a BCrypt password, there's a ton of CPU work that has to be done. And when a user logs into your site, it's going to make that action a little bit slower, but it doesn't really matter because the difference between half a second for a user login doesn't make a difference. But when you're trying to stand up to a brute force attack, it makes a big difference because you're looking at the SHA-1 algorithm where you can do 3 billion per second. So Rails makes this pretty easy. If you're using later versions of Rails, you can add the bcrypt Ruby gem to your gem file. You can use the hasSecurePassword method, which provides convenient accessors for reading and validating passwords using the bcrypt algorithm. And if you are using something like AuthLogic or RESTful authentication, Devise, anything like that, a lot of those have changed over the years how they store your passwords as people become more aware of these issues. So if you're using something like that, you should know what algorithm all of your passwords are being stored in. Were you using an old version that was doing SHA-1s, and now the latest stuff doesn't use that, but your database is full of SHA-1s? If you're not using bcrypt, you want to get onto a migration path to move those passwords over. That's going to take a little bit of extra work, but it's worth it. Third attack is what I call insecure direct object reference. That's a fancy name for a really simple concept, right? So everyone's written code like this before, right? We've got a RESTful controller. You're going to have the route be /accounts, account ID, messages, and then the message ID. So the simplest way that I might write this when I first started out, just look up the account based on the account ID, look up the message based on the ID, right? Really simple. The problem here is that you're letting somebody look up basically any message in the system, which is probably not what you intended. And even if you did have a system where everything was completely public and you should be able to view every message in the system, you still have a problem here because you can make a craft URL that makes it look like a message is under a different account than what it's actually under. So I could post a message and then change the URL to put someone else's account ID in it, and now it looks like they've posted the message to their account. For anyone who can get to click on that, it could be confusing and lead to different issues, right? So the fix here is pretty straightforward. You're going to use the associations finder method, and you're going to use that to look it up. So that's going to scope the lookup of the message to the messages that belong to that account. That's pretty simple. But the real failure here is authorization, usually. What that means is you're not actually going out of your way to make sure that the user has permission to view the object before you send it down to them. There are gems that can help with this. Can is pretty popular. Some people have said good things about it. I've heard other people complain that's a little bit complicated. But what I want to show you today is something really practical that you can bring back to your work next week and apply to your application to get authorization in place across the board. So here's a little module that I use in all of my Rails projects these days. It's called Authorization System. It only has two important methods. Authorize bang is a method that takes a block, and then it looks at the return value of the block. And if it's something that's falsy, it's going to raise a not authorized exception. Now, different applications might want to handle that different ways. You might want to log it to an audit trail. You might want to send the user a nice message or a not so nice message. And then you've got this other thing you're doing where you're keeping track in an instance variable about whether or not that method was called. And we'll see how that's used in the validate authorization check method in just a second. So the way you would use this, you just include it in your application controller. Now it goes on all of your controllers. And you're going to add this after filter. So after filters aren't as common, right? But what does it do? The validate authorization checked after filter, if we just go back, if that authorization checked IVAR doesn't get set in the course of generating that response, it's going to raise an authorization not checked exception. Now, this is something that's probably never going to happen in production. But the value here is, as a developer, when you add a new action to your application, you're going to be forced to add a call to authorize bang to that action. Otherwise, you're going to start getting an authorization not checked exception from your controller. So you won't be able to even test the thing locally. So you'll realize, oh, wait, I need to think about who should be allowed to take this action or view this object, and then you'll add code to the controller. So that would look like something like this. Really simple. You call authorize bang, and you can just have some convenience methods that you add to your domain. You don't need a whole framework to do this, that return Booleans that represent whether or not a user can access or create an object of different types. And because you're running this through a framework, now you have a secure by default system where authorization is going to be enforced on every page. OK, number 4, mass assignment. This has been a big deal lately. Most of you are probably familiar with adder protected and adder accessible, but just a quick recap. Adder protected is a blacklist. So if you have a sensitive field in your table, like say your user has an admin bit, you can say adder protected admin, and that will prevent a mass assignment from happening, which sets the admin value. The problem here is if you add adder protected, then you go on to add some other sensitive field in the future, or even if you just rename that admin to like is admin, now your adder protected is useless and you didn't know it, but you've introduced vulnerable code, right? You could be looking at a diff that changes the name of a field, and you're not going to realize that, oh, it doesn't change the adder protected declaration. Adder accessible is a lot better because it's a whitelist, and you say these are the attributes that can be accessed on this model via mass assignment. The big problem here is that it tends to vary by context. So you might have a customer notes field, which is only accessible to admin users in your system, to your company. But the end user themselves should not be able to read or write that field. So should it be in the accessible list or not is kind of unclear. And they've started to layer things onto adder accessible like context to try to fix that. But it all ends up being pretty complicated in my opinion, so I don't really like it. And of course, it makes testing a pain, right? Because in testing, you really want to be able to set up the object however you want to without having to worry about security restrictions. But adder accessible has been kind of the best way to do it for a long time. More recently, we've got strong parameters, which I think is a lot better. So with strong parameters, you are going to do a little bit more work in your controller, and you're going to keep this whole concern out of your model layer. So we see here in the update action, we're going to take the user params, and we're going to pass it to update attributes. But instead of passing params user directly, we're going to pass the return value of the user params method. So that does a couple things. If you look at user params, the first thing it does is it says require user. And that's just kind of a fancy way to hash into the user part of the params, because there could be multiple things in params. It has a nice behavior that if there's no user hash in params, it'll immediately return an invalid request response down to the user. But that doesn't normally happen if things are going properly. But the next part's the most important part. And that's where we say which specific attributes should be allowed through. So in this case, we say that the name, the email address, and the receive emails Boolean should be allowed through for this form. So basically, you're going to look at exactly which fields you expose in your form, and that's what's going to make their way into, this is a whitelist situation, right? But it's a contextual whitelist of what attributes should be allowed through in that specific spot. If you don't do this, you can get an exception out of your model that it won't let you just like pass random stuff in. So you get good secure by default. So I would say use strong parameters. If you're on Rails 4, you'll get this by default. Most of us aren't. But on Rails 3, there's a gem that you can add to your application. It works really well. I wish it would have made it into like a point release of Rails 3, but you can use it with no problem on Rails 3. Okay. Number 5, cross-site request forgery, sometimes called CSRF. This one's a little complicated, so I'm going to diagram it. You've got a victim, a malicious site, and a target site. Now, what happens is the attacker is going to trick the victim into viewing a page on the malicious site. Maybe they send them an email or an IM with a link to the malicious site. So the victim makes a request, right? This shouldn't be that risky. We shouldn't have behaviors where if a user clicks on a link, their whole computer gets compromised, right? Like that's not the way the web should work. So the malicious site then sends back a response. And in that response, they've got an image tag. But rather than pointing at an actual image, it's pointing at a URL which has the semantics of purchasing stock. And that URL points at the target site. The issue here is that the victim's browser is now going to make a request to the target site for that URL. And importantly, it's going to attach to that request the session. Not the session for the malicious site, the session for the target site. So if the victim is logged in to the target site at that time, and that buy.php action is sitting out there in the open, all someone needs to do is get the victim to visit a malicious page, and they can purchase stock on behalf of that victim, right? Does that make sense? So Rails does a lot to help with CSRF attacks. They have this protect from forgery directive, which you just need to include in your application controller file, that will largely defend against this stuff. I've seen a lot of apps, though, that don't have this there. Maybe they were generated before it was added, or they turned it off because they ran into some bug. You want to get this in there. It might cause you a little bit of pain to make sure your JavaScript works with it, but you need this. And then once you have that, the only other thing you need to do is make sure that all your gets are safe. The CSRF protection does not do anything about GET requests, so you want to make sure that none of your dangerous actions are available in the router for as using the get verb, and you're not using get for anything dangerous. Otherwise, you'll bypass that whole thing, right? So don't create a hole that way. Okay, number 6, offsite redirects. So this is a really common pattern, right? You have a sessions controller, and then after a user logs in, you're going to send them to the destination where they were headed, right? So you gate them, you show them login, and then afterwards you send them on their way, or if they don't have a place they're going, you're just going to send them to the default homepage. The issue here is that if you have an attacker who crafts a URL that sends in a destination that's unexpected, they can basically cause your application to bounce users to a place you don't expect. So that can open the door for phishing, and then sending users to malicious sites where basically you're violating the user's trust because it looks like you're sending the user to wherever, but actually it was an attacker who created a special URL. So there's 3 different ways that you can kind of deal with this. We'll go from good, better to best. One thing you can do is if you're ever taking params or untrusted input, like an attribute, and using it as the basis for a redirect, you can verify the protocol and the host before you do the redirect. A little bit better than that would be if you can create a whitelist of the specific URLs that are allowed, then you can validate against that. And the best thing you could do would be to actually, rather than passing a URL in that parameter, just pass an identifier that indicates where the user needs to go, rather than having a full URL for where they need to go, right? So it just might be a string that says, I'm going to send them to checkout, or I'm going to send them to the profile page. And just put profile or checkout in that param, and then map from there to a specific route. And you don't even open the door for this. Number 7, unexpected code execution. So there's 2 different kind of ways that there can be unexpected code execution in Rails that I'd like to talk about. The first is leaky routes. So if you have routes like this, you have a problem. The first route exposes all of the actions in the reports controller. So that means that anyone can craft a request in your application where they're going to cause a method inside the reports controller to be invoked, or any of its superclasses. And the match route at the bottom, this used to be kind of like the Rails default. Right now it's commented out, and we're all moving away from this, but it's pretty bad because it means that anybody can pretty trivially create a request to your application that executes any method inside your controller layer. Now the problem with this is that you've got a case where controller methods generally expect that certain context is available to them, right? They might depend on the fact that IVARs exist or that certain parameters are present. And when you start running different methods out of order willy-nilly, it can be really hard to guarantee that all that stuff is safe. So you don't want an attacker to be able to start poking your application in that way. So you want to use strict routes. You want to list in your routes file. If you're using RESTful stuff, you kind of get this by default. But you always want to list exactly which actions you want to be exposed. And the second type of unexpected code execution is unsafe render calls. And usually this crops up when you want to render either a page or a partial based on something for convenience, right? You have this convention that you set up where maybe you've got a user who has a profile or a dashboard, and they can pick which type of dashboard they want, and they have a drop-down to pick that. And you say, well, OK, I'm just going to create 3 different templates in the same directory, and they're all going to be named with the same values that are in that drop-down, and I'll pick it based on the user's attribute what we want to render. The issue here is the user can control the dashboard template attribute, right, because it's on their preferences page, and they can start putting in values that you're not expecting, right? They can put in something that is like dot, dot, slash, dot, dot, slash, whatever. And you don't want to allow them to force your application to render things in that way, right? Because just like templates are just like methods, they can do anything, right? They're evaluated Ruby code, so all the same risks apply. So if you're doing something like this, you should move to a whitelist system, where you say, like, these are specifically the templates that we expect to be passed through, and then you're going to avoid this issue. OK, number 8, SQL injection. So Rails does a pretty good job of protecting you from SQL injection. It does better than most libraries and frameworks. So you see this sort of code all the time. This is searching for a project based on name. You can let the request drive what's going to be sent into param's name, and it's still safe, because the contract with active record is regardless of what's in that string. It's not going to let you break out and run a SQL injection attack. Now, active record could have a bug that makes that not true someday. That's kind of, there's a lot of people looking at that code. That's going to be a really big issue that's going to be reacted to very quickly and patched across the board. So you don't want to have to do this sort of stuff yourself. You want to depend on the folks that do Rails to do this for you. But there are some issues that you need to be aware of. So the pluck method, for example, is normally used to just pull one specific value out of a relation and return it as an array. And you would think, maybe I would think, that if you let the parameters control which column goes into pluck, the extent of the risk here is that somebody could pluck a different column off the orders table, right? So maybe I was planning on them plucking subtotal and total, but instead they pluck line items count or something. And there might be some risk there. But it's actually much more significant than that, because that method parameter can take arbitrary SQL, and then you can start manipulating the query in really interesting ways, right? So even though it's an order pluck, if I pass in the right thing, I can now start querying passwords out of the user's table. And now we get into this brute force attack thing, right? So you have to look out for the active record API in ways that it might work that aren't particularly obvious right off the bat. Order calculate, same thing. You might say, OK, well, maybe I can just pick different fields in order to calculate. But no, you can start actually pulling specific values off specific, totally different tables at your convenience if you have code like this in your application. So you have to know the active record APIs, maybe a little bit more than you originally thought. I was kind of blindsided by this as well. But there's a really good website, Rails-SQLI for SQL Injection.org. It was done by Justin Collins. He's on the Twitter security team, really smart, and just covers all of the different places in the active record API where you can pass in SQL, either as an attribute or as a parameter, and it will make its way down to the database. So just look at the APIs you're using and see if there's some places that might be a little bit more risky than you thought. OK, cross-site scripting, big one for the web, right? Let's look at how it works. So an attacker sends a malicious script into the target website with the hopes that the target website then sends that script down to a victim. And if that works properly, then the attacker can do all sorts of interesting things. They can make the user's browser, it's now executing script that they control, but in the context of the victim website, which means you can do things like stealing the cookies and sending them up to a malicious server. And from there, it goes on and on and on. So cross-site scripting is probably the biggest web security issue that's out there today. It tends to be very prevalent. The impact is very high. If you can run script on the page, you really need to watch out for this. So what can we do in Rails to mitigate against cross-site scripting? Well, Rails XSS, which was a plugin and then dropped as a default behavior in Rails 3, goes a long way. That's that stuff where everything becomes escaped unless you tell it to be rendered unescaped. If you're accepting user-generated content, like let's say people are submitting HTML as part of their profile, you need to go a bit further and look at something like Loofah, which will actually let you take HTML and run it through a sanitizer and only allow through safe HTML elements and safe HTML attributes. That's if you're doing UGC. And then if you want to go even further, there's some new technology which I think is really cool, but I don't have time to talk about it today, called content security policies, which works in more modern versions of browsers. And that lets you set a rule that says, okay, browser, don't run any external script on this page. Don't run any inline script on this page. Only run script from my CDN. And it gives you a really good backstop where if everything else fails, content security policies might be able to save your butt. So check it out. The risks in cross-site scripting in Rails, if you're talking about modern versions of Rails, anytime you're calling raw or HTML safe, you want to be very careful, because now you're saying, okay, I want to bypass the security mechanism that's been created, right? Anytime you're bypassing a security mechanism, those are the first places I'm going to audit in an application to try to find a way to sneak something through. Also, link to href attributes. You might not realize this because everyone's doing kind of unobtrusive JavaScript these days, but if you have code like this, where a user can set a homepage URL, and you're just expecting them to give you a URL to their MySpace page or whatever it is, and you're just going to render a nice link so you can click through conveniently. Well, the user homepage URL attribute, if that starts with the string JavaScript : it does exactly what you would expect. Rails doesn't help you at all in this regard. I actually think this is an insecure Rails behavior because people don't realize that this is a risk, and people don't use that JavaScript style URL that much anymore. I think you should have to like pass an attribute into Rails to enable that. But for now, you have to be very careful about anything that makes its way into the href attribute of a link, and link to won't save you from that. Okay, it's 2013. We're doing a security talk. It would not be complete without talking about YAML. So, the learning this year, to summarize, is that YAML is equivalent to eval, not email, eval. And that kind of broke with the Rails security issue that dropped in January. But I want to look at a little bit about why. If you haven't dissected this, this is a super interesting way to just digest a security flaw that has a few different layers to it, but it's approachable. If you spend some time reading about it and looking at the example proof of concepts, you can start to craft your own and play with it, and it's kind of just a cool thing to tinker with. But this is an example of a malicious YAML payload. And what we're doing here is YAML allows you to serialize arbitrary Ruby objects. So we're serializing a named route collection. But if you look at the source code for named route collection in Rails, you'll notice that it defines the brackets equals method. And if you follow that a few stack frames down, it actually ends up class evaling the value that's passed in. Now, normally that's fine because it's used to basically define routing helpers. And that works really well. The issue is, just by YAML deserializing a malicious packet, it's going to eventually hit that code path and let you eval arbitrary code. So when this was being worked out, originally it was like, well, we can start stuffing stuff into the object, and that might create a risk. And then people started looking at what objects were defined in the processes. And actually, there's some classes where if you just inflate the object, you're already toast. You already can eval code. So I would say avoid YAML. I hate YAML because it looks safer than it is. Like if you just put eval, that would be better in my mind, because anyone who looks at that is going to say, okay, well, that's an eval. I better be really sure about what's going through here. If you YAML.dump, you might as well be, or YAML.load, you may as well be saying eval. So I don't like it. If you want to avoid it, you want to look at your calls to active record serialize. The default serializer is YAML. Store is newer functionality that's built on top of that, same caveat. And also your work queues. So if you're using like delayed job and you're serializing your work into YAML, you may be creating more risk than you expect because somebody can put code into that. If they can somehow inject information into your work queue, then they can springboard that into evaling and taking over your whole application. Okay, so those were the attacks and the countermeasures. I'm going to give you another thing which is super practical you can bring back to your job, and it's this: run Brakeman. So Brakeman is a static analysis tool that's developed and funded by folks at Twitter. It's really, really high-tech stuff. I don't know if anything like this exists for other languages that's this good. So it looks through your application, and it finds places where untrusted input might be going in, like parameters. And then it follows the flow of your application to see where that stuff is eventually used. So if you interpolate parameters into a string and store that in a variable, and then in another file you pass it off to active record, it can actually track that and say you may have a SQL injection vulnerability that you've created here. It's really easy to install and run because it doesn't actually run your code. It just analyzes it, so it's really compatible with things. Gem install Brakeman, generate a Brakeman report, and you get back something like this. It's a little hard to read, but each of the rows in that table are actually a specific instance where Brakeman said, you know what, there's code in this application that may have a vulnerability associated with it. I've never seen anybody run Brakeman for the first time and not get back at least one thing that they said, you know what, this is worth fixing. So if you haven't run it, there's probably some security issue that that's gonna pop up right away that you can fix. So this is something you can take back, run this against your application tonight, tomorrow, or on Monday when you get back to work. The company I work at, Code Climate, company I own, recently launched a feature called Security Monitor, which is based on Brakeman. So if you don't want to run it yourself, we can run it for you, give you a nice web UI. We can also send emails if a new vulnerability gets introduced. But one way or another, run something that's based on Brakeman against your application. I won't be offended if you don't use Code Climate for that. The last thing is I'm working on a free book that's going to be at railssecurity.com. The goal is for it to be the most comprehensive and in-depth reference for application security risks that are facing Rails applications and how to mitigate the attacks that are out there. There's the Rails Security Guide, which is quite good, but this is kind of broader in scope, and it's going to be free and published under the Creative Commons license. So I'm just really trying to raise awareness and get people more familiar with this sort of information. So if you like the content that was in this talk and you want more, because obviously I can't cover everything in 30 minutes, check out railssecurity.com. You can toss in your email address, and we'll email you when the book is published. That's all I've got. Thank you very much for your time and attention.